Hello world, it's Andrew Engineer. Okay, so we are going to continue with our lesson on mapping, but now we are going to go more deeper into analysis. Okay, we are going to learn the detailed analysis. Okay, of our results. So as you can see here, we first of all started. Please make sure to subscribe to our channel. Okay, various media social media platform, and more particularly to our YouTube channel where all these videos are uploaded in advance. Okay, so here we're on map on member. That's what we used in the previous scenario. Okay, for example, to see the bending moment, you choose my, the force mx. Okay, now there's another approach you can use. Actually, diagram of bars. Actually, you come here simple. Okay, on forces you make sure you normalize, and then you apply. You see it has been applied already, but let me show you some parameter first of all. Here you can see that you have some parameter to set up, and here is under global extreme. It simply means what? It will give us the highest value of the load carrying by our columns and the smallest value of the load. Okay, so if we go to local extreme and then we'll click on apply again, you see that it will give us many value now per member. Okay, the value will be given per member. It's the same if we do the this thing. We do this diagram of bar for our beams. Okay, you can see how the load of a column is increasing as we are going down. Like, more we leave from the last floor to downstairs, the load is increasing. That's why we are usually saying that the structure can be built in such a way that the columns downstairs can have higher section and the one upstairs don't need that very section that you had at the ground floor. Okay, because it will just be a way of misusing your concrete, or just how would I say, using too much concrete for nothing. It's not an optimized result, in other words. So this is what I wanted to show you. Let me select a different force. Okay, let's choose the moment. Let's unactivate the this thing and choose the moment. Then we apply now for the moment. From the moment now, you also go under parameter and make sure we choose global extreme, so that it give us the maximum moment. I make sure we are on combination one, which is the ultimate limit state. Okay, so this is the maximum member. Let's shift a bit like this. Let's try to rotate to be able to really find where this maximum okay, is member 444. We'll select it, then we'll isolate that member. Okay, when you isolate it, that's how it look like. Okay, this is actually to enable you, maybe that you don't like maybe we're going to calculate, or you want to check your result manually. You can actually use this because you have the maximum bend moment. You can do the same with the shear force and make your manual calculation of your reinforcement. Okay, so when we are here, as I was talking of detail analysis, we go under result again, we click on detail analysis. A new window will open like this, and then this new window will actually enable you, in order maybe to, when you have a presentation or something to show to people, you can actually use this window to present, to make screenshot or screen record of your result, to be able to discuss and explain it better. As you can see, we have all the characteristics, the names of the bar 443, beam number 2, long the length, which is 3 meter 93. Okay, is my robot is somehow in French. Okay, that's why it's written longer. So this is the maximum bending moment according to global extreme. Okay, so we can also make sure that yeah, okay, this is the global bending moment. This is the shear force that is being the shear force diagram that is already represented. I wanted to say let's activate the shear force. So this detail analysis actually gives you this view, and then here you can have this all this the information above on the diagram, just on the table down here. Okay, so this a bit local, this about your local extreme. Okay, give the position where all those load are being identified, the maximum load at the and the distance at which is being identified. Okay, as you can see here, we have 440, we have -0.45 meters. Okay, yeah, and we have the value here, the force, the shear force here, we have the bend moment here, and we have their value. Okay, so if you go to global extreme, you still have the same. We have the maximum value, okay, and the minimum value. So this a bit, let's say this the little explanation about detailed analysis. You just go under result, okay, and then you click on detailed analysis to have a better overview of your element that you wish to provide a reinforcement. Okay, uh, so I would say let's end for here for this lesson. I think in the next lesson we can start maybe providing reinforcement. Thank you very much. It was Andrew Engineer.